A binary ionic compound is made up of one type of metal element. So everything on here that's on the left side of the periodic table, and one type of nonmetal element. And the metalloids can react as well, and it kind of just depends on the compound how you're going to name those. So there's some instructions for naming binary ionic compounds, and binary just means two. So these have two elements in them, one metal and one nonmetal. So when you're given the name of the compound, find the elements on the periodic table. Look at their most common charge. It is written at the top of the group on your periodic table. Write the charges above the elements in the compound. So I'm going to go ahead and fill them in on here. The first column is +1, +2, +3. Carbon's column can be plus or -4. -3, -2, -1, and the last column doesn't react. That's 0. So down here on the examples, we're going to find out the charges for barium and chlorine. So if you look up here, barium is right here, number 56, so he is Ba +2. Chlorine's over here, he is Cl -1. Sodium is Na +1. Oxygen's -2. And aluminum is +3, and sulfur is -2. So all you have to do is look at the top of those columns to figure that out. So all compounds must be neutral, or their positive and negative charges must equal 0. So for every single one of these compounds, you have to have 0 charge. So in order to get barium chloride to cancel out, you have 2 positive charges from the barium. You have 1 negative charge from the chlorine. And we want the charge to equal 0. So you're going to need 1 barium that has 2 charges in it, 2 positive charges, and 2 chlorines will cancel it out. So you see if you have 2 of these, that's 2 negative charges, and they'll cancel out with this one. Another way of thinking of that is you can just switch the charges. So the charge that went with barium, that number now goes with chlorine. The charge that went with chlorine, that number 1, now goes with barium. But you don't have to show the number 1. Let's try this for sodium oxide. You have 1 positive sodium, and you have oxygen with a -2 charge. Again, if you just switch the charges, so bring this 2 down here, and the 1 down here, you actually don't even have to write the 1 down. So the total formula for this is Na2, Na2O. And this one is BaCl2. So you get really good at this, and you won't have to show the charges every single time. Alright, for aluminum sulfide, go ahead and pause the video and try this on your own and see if you can do it. Alright, aluminum has +3, sulfur has -2. These numbers don't go into each other. So think about what you would need to multiply these by in order to get this to work. So let's say we had 2 aluminums. That's a total of 6 positive charges. How many sulfurs would we need to make 6 negative charges? If you said 3, you're right. That would be -6. So in order to write that formula, we would have Al, you can bring the 2 down, 2, S, 3, and that's aluminum sulfide. Let's say you're given the formula instead and you need to write the name. First thing you need to do is name the metal. And I put on here, easy. It's the same as the periodic table. So whatever the metal name is, you just write that name down. Then you're going to name the nonmetal. So you're going to remove the last syllable of the element and add "ide." So oxygen turns into oxide, sulfur turns into sulfide, phosphorus turns into phosphide, and so on. So let's try these down here at the bottom. Split it into 2 parts. Everybody has a first name and a last name, just like people. So this first name, Li, is lithium. And the last name is a fluorine, so that turns into fluoride. That's all you have to do there. All right, the next one is magnesium. Now there's 2 iodines here, but that has to do with the charges, so you don't need to worry about that for right now. We just call this magnesium iodide. And I didn't put that up here, but you can add it in. Iodine makes iodide. And then we can pick any other example we want. I don't know, let's do cesium and I don't know, sulfur. So that would make this compound, it'd be cesium sulfide.